And we'll begin class in 3, 2, 1. Good morning!
Good morning.
Hi everybody, my name is Mr. Boda. Welcome to 9th grade science. Here's what we're doing today. As you can see on the board, your instructions are to have your density notes out. Thank you for having your density notes out. We're going to finish those today. The reason we're finishing the density notes is you need to know how to calculate density, right? Why do you need to know how to calculate density in my class? Shout it out, shout it out. Sludge lab exam. You have to identify a bunch of stuff, right? Could measuring and calculating a density be a good way to identify some things? Yes. In fact, not this class, but next class we're going to do a lab where I'm going to give you some weird pieces of metal. They're odd shapes, and you're going to have to figure out how to find their volume and their mass and calculate a density. I know right now, I'm apologizing ahead of time. There are students in this room and watching me right now for whom this math will be easy. I understand that. There are also people watching this video and in this room right now for whom this math will be cutting edge and new learning for you. It is intermediate algebra level. It's like right, if you're in Swigham's class, like 9th grade math, you're doing this stuff right now. If you maybe if you're in like algebra 1 or geometry or algebra 2 or some other crazy math, this will look very familiar to you and you'll blast right through it, which is awesome. But everybody's got to learn like my version of how to do it so that you can do it on the Sludge Lab exam. Okay, sorry. What are we talking about? Density. We're talking about density. We're going to be taking notes real quick. I'm going to yell about some stuff. Then you're going to do 2 worksheets. You're going to do the yellow worksheet in class. Try to do that solo if you can. The substitute has an answer key if you get stuck on any. The point is not to get the right answer though. The point is to know how to do it. Right? And then the blue one's a little bit more difficult, the blue sheet. If you want to work on it with a partner on that one, you totally can. Watch out on the blue sheet. There's like some trick questions in there. You got to think. You got to think. Any questions on what we're doing? No. Anybody from the video? Huh, I can't hear you. So. Here we go.
You guys say like Dora.
I don't even ever watch Dora.
You've never watched Dora?
How old do you think I am, you guys? I appreciate that you think I'm young, but come on. Dora had not been invented when I was a kid. Can you, on your density, can you scroll with your eyes down to the mass and weight section? We already talked about volume, right? Yeah, volume is, our definition of volume is the amount of space an object takes up, right? We've got volume. We figured out how to calculate it. We talked about a cubic centimeter is the same as a milliliter, right? Yeah. We talked about the definition of a meter. Did we talk about the definition of a meter?
Mm-hmm.
Yes.
Yeah. It was originally a piece of metal in Paris, right?
Yeah.
Like, this is a meter, this piece of metal. And now it's like how far light can go in a certain amount of time. Did we talk about that?
Yeah.
Yeah, which is cool. Okay. So mass now. Remember, I'm talking to kids on video also, so if you already have these notes, sorry. Mass is really specific. We measure it in kilograms. This is a kilogram, right? That is a kilogram. It's actually a copy of a copy of a copy of the kilogram. It's a copy of a copy of a copy of the kilogram in Paris. It's the stupidest unit. If you're watching and you haven't seen it, we'll talk. I can't do it right now today though, because it involves too much yelling. Mass is
The amount of stuff matter in an object.
Thank you for reminding me. The amount, I did actually know, it's a teacher technique. The amount of stuff, parentheses, or quote. If you want to get stuff, I go matter. If you want the more scientific word, which you should if you're in my class. Henry, what's the actual official science definition?
An object's resistance to acceleration when subjected to a net force.
Boom! Yeah, we'll talk later about that.
That's cool.
But the reason that mass, the reason that's the official definition, is that things that have mass resist acceleration. You know that if I try to make this go faster, I'm going to have to push, right? Because it's got something called inertia. Have you heard of inertia? Mm-hmm. We'll talk more about inertia in like 6 units from now. But that property of inertia is what we actually define mass with. Anyways, for us, for 9th grade, it's the amount of stuff in there. The amount of matter or stuff in an object. What's the current official units of mass, everybody?
Kilogram.
The stupidest units that we have left. All the other science units have been defined really much better, but we're still stuck. The actual definition of a kilogram is the amount of matter in a piece of metal that's in Paris. It's a cylinder, it's a piece of metal this big, and that's the kilogram. And we compare everything to that one original kilogram. We could also, instead of kilograms, we could subdivide this. If we go into thousandths, it would then be called a Yeah, that's a gram is 1,000, like 1,000th piece of that kilogram. That's that. Oh, Beatrice, I gave you my version of that. Yeah, let's talk about weight though. You all have measured your weight at some point in your life, I imagine. I measure my weight every couple days just for funsies. It never changes. It's weird. It's kind of like a parlor trick. Weight is not the amount of stuff in me, actually. Weight is something's happening to me. Why do I weigh stuff? Gravity. What's gravity doing to me?
Pushing down.
Pulling me down, maybe. Yeah, pushing or pulling me down. And then because of that, what do I do on the ground?
Stand.
And not only do I just stand on the ground, but I am actively
Pushing the ground.
I'm pushing into the ground, right?
Is that why we make footprints?
Yeah. Weight is a measurement of how hard I push onto the ground. Weight is a measure, record this. Weight is a measure of how hard, it's a measure of how hard gravity pulls you down. It's a measurement of force, by the way. That means it's a force. Weight is measuring the force that you push on the ground with, which is why we measure your weight in pounds, because pounds is actually a measurement of force. Did you know that?
No.
Like if I was to measure how hard I punch this, I would measure that in pounds. That's a measure of force into the thing. I'm not going to really push it. Yeah, PSI is a measure of pounds per square inch. You use that to measure pressure of gases or liquids. Or you could measure, even the pressure on the knuckle into the metal. Let's not do that. That was a silly example. That's a little different than mass, though, because mass is how much stuff is in me. If I'm in space, do I still have mass?
Yeah, but you weigh less.
If I'm in space, do I have weight? Like,
No.
Not necessarily.
why?
Because there's no gravity.
That's totally not true. There's lots of gravity in space.
It's not pulling you down.
Yes, it is.
What is? It's not fat
I
harder.
know you know that.
Not like here. Where's the ground to push you on?
It's right under you.
Like, no, but in space.
Like way down under you if you're in space, right? It's way down here. But why do you float in space?
Gravity isn't strong enough.
There is gravity in space. It's think about it. Why does the moon hang out around us? And why does the moon not just sail off? Because of Earth's gravity. So Earth's gravity is strong enough to pull all the way out to the moon and keep the moon to us. So if the moon's out there, Earth is here, an astronaut is like here, right? So it's still well within Earth's gravity field. The gravity is a little weaker up there, but not weak enough to make you just float. Henry?
Because relative to your frame of reference, there's no gravity.
Frames of reference. There's a great video that you're gonna love in a couple of weeks. Months. Let's talk about what it means to be in space for like 2 seconds. Space. We gotta talk about space.
Isn't like water like?
No, water's not in space, man.
No, like because astronauts they like test their stuff in water.
Yeah, because water slows down the pull of gravity. So and you're buoyant in water is really what it is. You're kind of floaty, so they can make you buoyant, and then that simulates, gets us close. That floatiness of being in water can simulate space. I can't get into it. I'm gonna draw like